fixes that. Hey, Mr. DePena.
Hey, how's it going, Dan?
Going darn well. We are in the throes of trying to go live with Houston DevOps Days in a month. You can imagine.
Yeah, I know. I know.
Absolutely.
Yeah, I can imagine. I was going to submit a speaker topic, but as it turns out, I am actually leaving AWS.
Oh no.
No,
is this good news or bad news?
It's good news. It's good news. I'm going to move back into a more builder-centric position.
Welcome to the Houston DevOps Meetup. This is an off-cycle meetup, so we're doing something kind of special here. I was looking forward to getting Rob and I into the pipeline, and we finally got him on this particular one. I was talking with my org today about DevOps, and what my boss asked me to do is, my boss at ABS, we were talking, and she asked me, she said, how do you know you've walked into a shop that's doing DevOps and doing it well? You know, not just anything bad is still bad, right? So how do you know when you walked into a shop and you're doing it right? And so I put together a list of 11 things, you know, optimally, these are the things that wind up manifesting. And one of the things that struck me, and it struck her as well, because we talked about the word precision. What you see in DevOps shops is precision. You see, there's not a whole lot of hand waving going on. You don't have people stepping up and, okay, well, we might do this and it might work, and no one's ever held accountable, and no one ever kind of estimates what they're supposed to be doing or how that's supposed to help. No one's kind of, it's all data driven. There's always a way to point and say, okay, this was good or this was bad, but it's never, of course, in a blaming kind of sense. It's precise. It's empirical. It's ultimately, it's the way that we all as engineers want to work at a science level, right? So we were having that conversation today around the company, and how can we gather enough of information to know where the bottleneck is, and how can we attack that bottleneck. So yeah, DevOps means a lot of different things to a lot of different people. So what happened with on my journey as an IT professional, I just came to a realization that, boy, the cloud moves fast. And I can't know it all. I am not that smart. I need people around me. I need somebody that knows how to do this. I need somebody that knows how to do that. And one of the things that I keep running into is this idea of cloud native storage that we'll be talking about with Rob and IO. Content is everything. And if you can't get that content to people, you're going to have a lot of problems. And so how best to store it, where to put it in a world where cloud is supposed to let us not care where that data is stored. We've got all these GDPR and PII and CUI, there's all these acronyms around data residency, and you've got to know where it is, and you can't let this data cross this boundary according to this cybersecurity law. And so you've got all kinds of players in that. Like China's got a big old cybersecurity law, but heck, Morocco put one out there. I don't know what they're going to do to enforce it, but there are small players, big players, and of course, in the United States, we have some pretty strong cybersecurity stuff that we're trying to get in place. So, all that being said, this is a timely meetup. I'm looking forward to the presentation.
All right, everyone. Thank you. First of all, Dan, thank you very much for having us here and giving this opportunity for us to present our cloud native solution, right? And thank you, everyone, for joining this evening. And I'll go over, the deck and present our solution, and also, show a demo of our product, in one of the Kubernetes clusters, right? Okay, so so over this decade or so, Kubernetes has solved, a lot of lifecycle management and orchestration problem for a stateless workload, right? But more and more enterprises and organizations are trying to onboard their stateful workload, so databases or any stateful workload, right, on Kubernetes to take advantage of the operational simplicity and the lifecycle management that Kubernetes offers, right? So, but when it comes to storage, deploying stateful workload on Kubernetes, we are just looking at the tip of the iceberg, right? So there are a lot of things, a lot of consideration that needs to be looked at before enterprises can, select or build some, select a storage, right? As you all know that, Kubernetes does not have a built-in primitive for storage, right? When you deploy Kubernetes, it does not come with software-defined storage or storage in any form. Kubernetes provides a CSI interface through which you interface external storage, software-defined storages like Robin and other storages, and with that, you should be able to persist the data. Right, it was kept by design that way to keep the storage external to the orchestration platform, because storage in itself is a very complex domain and it requires specialized knowledge, right? So what are some of the considerations that the enterprises should look at when they are selecting a software-defined storage for Kubernetes, right? One of the things is that the data should always be available, even if pod or disks or server fails, right? That is one of the promises that Kubernetes provides, is that when there is a pod fails, it fails over to another host. If a host goes down, all the pods in that host relocate to another host. Now, can your storage do the same? Right, so it needs to have replication. It needs to have other constructs to provide the same kind of guarantee that Kubernetes offers. Now, the second one is, this is a cloud native way of doing things. So now the DevOps is responsible for building and deploying applications on Kubernetes, including the stateful workloads, right? In the world, where you have legacy applications, right? So you have an application, you're talking about all the infrastructure servers, and there is a storage admin who is responsible for providing all the storage functions. But with Kubernetes, that is becoming, less and less normal, right? Kubernetes, it needs to be handled through the DevOps team. That means that the operations that are required to be performed should not be requiring any storage expertise, right? It should be seamless for the DevOps team to deploy and manage their application. And the storage should provide a predictable application performance, which is very critical for enterprise workload, and also because Kubernetes is hyperconverged infrastructure, and there are a lot of shared applications that will be sitting on the infrastructure. And the next is, because we are talking about stateful workload, the stateful workload means that there is data, and data has gravity, and also it requires maintenance. Right.
What did you mean that it's hyperconverged infrastructure? I mean, the pods don't automatically fail over. There would have to be replica sets, right, for the pods to fail over. And what did you mean by, as far as the hyperconverged? I'm sorry that I'm late. I got stuck in traffic, so I might have missed the beginning of the presentation that kind of outlined that, Raj.
Oh, no issues. So we were talking about in a hyperconverged infrastructure, how Kubernetes.
Oh, okay, sure.
Right. Yeah. So we are talking about what the need for a storage solution to deploy and manage stateful workload on Kubernetes. And when you have to select some storage solution, what are the things that you have to look at is what this slide is all about. This is the first slide, so you didn't miss a lot. Okay. Yeah. So yeah. So the storage requires data management, right? You have to think about how do you take snapshots, clone, and backup, and how is your DR going to be handled for business continuity. And then finally, you need an observability capabilities to maintain and manage your day-to-day operations. Right. So at Robin, we have we have been doing this for over 6 years. We are based out of San Jose, and we originally came up with the product, which is a complete orchestration that leverages Kubernetes, and it comes with the storage stack as well as everything that is required for Kubernetes. But then we introduced this storage as a CSI plugin. Now this works with any Kubernetes. Storage has been in use by a lot of enterprises that run several stateful workloads. And like I said, the storage can be deployed on any Kubernetes distribution, including open source, OpenShift, Anthos, GKE, AKS, etc. Right? And this is a software-defined storage. There are no appliances involved. And once the software is deployed, it pulls together all the resources that it can see in the system and creates a single pane of window as it comes to storage. Basically, it creates all the disks that are local to the each of the hosts that where the cluster is deployed are pulled together to create a storage fabric similar to vSAN, right? But it's much more than that, just to make it to give some parallel there. And we are recognized by industry-leading analysts, and there are a lot of our customers use it. So let's go and look at what are the day zero capabilities. So when it comes to storage capabilities that software-defined solution can offer to Kubernetes, right? So we define all the capabilities into two buckets, right? The day zero capability is, so the solution, the Robin solution comes with, it installs as a lightweight operator, and it runs on any Kubernetes. It discovers and pulls local disk, SSD, HDs, and NVMEs, and it provides off-the-shelf compression and encryption and key management for your encryption. And it is highly available, and it provides strictly consistent replication for your data volumes. And fast failover is available. And then we also, the solution also provides advanced placement capabilities. You can co-locate compute and storage locally, if certain applications require that. And then there is a node, rack, and data center replication with fault domains at node, rack, and data center. And we support multiple data access modes, right? Rewrite many, rewrite once, and read only many. And also there is a support for file and block storage, right? So these are the capabilities that are required to deploy your application, right? So you have now deployed your application. So what happens next? Right, like I said, this is a stateful workload. This is not just microservices where you fire and forget. And with the constructs that you built with your Kubernetes objects, right? It automatically takes care of failing over or scaling out, scaling up. But that cannot be said for stateful workloads, because that requires additional capabilities, right? So then those capabilities, we call them as day one capabilities, which is performance, right? So our solution has been measured to have a little bit tax than the bare metal performance. Obviously, we cannot beat the bare metal, right? That's the base, and we have a slightly little overhead, so we give close to bare metal performance, and the solution provides live data rebalancing to avoid I/O hotspots, and you can cap IOPS to avoid noisy neighbors. And from a capacity management standpoint, you can add and remove disks, and increase or decrease volume sizes, and you replace faulty disk without putting the whole host at maintenance, right? And then the solution provides an observability, a lot of tools that for observability standpoint. We can talk about that. And then from a data management standpoint, we support snapshot, rollback, backup, restore, and cloud mobility for your application. Right. Oh, I think I'm using a different slide. Sorry, hold on one second. Okay. All right. So I have this. So at the core of our data management capability is how we look at the application, right? We look at the application holistically. Um, mm, um, by that, what I mean is that when an application in Kubernetes consists of metadata and config data and the data itself, right, which is in the form of volumes, PV and PVC. Data management operation that you perform in Robin using Robin by default does everything at the application level. So what this means is that if you're going to deploy a Postgres database or a MongoDB database or any other application, when we take a snapshot, we take the snapshot of the entire application. That includes all the metadata about the application, all the objects that goes with it, and the data itself, right? So this gives us a few capabilities, which we will see in the few slides. So ensuring that we look at applications holistically provides data consistency for applications when there are more than one volumes involved. For example, let's say, for the lack of a better example, Oracle is an example, right? So it has multiple different volumes. And when you're taking a snapshot, if you want to use that snapshot, you have to have an app and crash consistent snapshot across all the volumes, right? Registering an application, so you can deploy application using Helm chart, or operator, or using YAML files. It doesn't matter, right? So when you deploy the application, and when you use Robin as a storage class, Robin will take care of managing the application.
Could you go a little slower back to the Oracle comment about the snapshot? What was that? What was that you mentioned? Sorry.
Yeah. So I was explaining that why do we need application perspective in Kubernetes, right? So I was saying that let's say that if an application like Oracle, the reason why I brought up Oracle is that Oracle has multiple different volumes, right? There's a redo volume, undo, log, and then all these volumes, right?
Yeah. Those could all be on the same volume. So you know what I mean? When you take a snapshot, you're taking a volume, but where you put those mount points is up to you, right?
Right, but there are for performance considerations, right?
Yeah. For performance, I use separate. I use separate volumes.
So when you
I could use a transaction log or redo logs, right? Sorry, you're just going kind of quick. Just when you spoke about it, it didn't make sense. Sorry, I threw out the question too on the software defined. Sorry about that. I came in late, so you were mentioning a software defined as I was sitting down.
Okay.
Sorry. So go ahead. I didn't mean to interrupt, guys.
Okay. All right. So all right. So when application is deployed, Robin auto discovers its data, metadata, and configuration. And whenever you need to perform any of the data management operation, we perform at the whole level. And just wanted to also say that this is not, you can also, if you choose to take the snapshot or clone at the PVC level, we support that. We support application level PVC and namespace level granularity when it comes to snapshots and the other operations that depend on snapshot. Okay, so the snapshots. Snapshot is so with Robin's with single command, Robin makes it easy to take a snapshot of your application, right? So when I say application here, it's a deployable unit through Helm chart or operator or your YAML, right? Everything that is part of that. It could be more than one services in a database or several applications stitched together like Elasticsearch, Logstash, Kibana. So we call the entire thing as an application, right? So now. So what are the use cases for snapshot, right? The snapshot, and before I go into that, our snapshots capture, like I said, apps, data, config, and metadata, and these are application and crash consistent. The snapshots are incremental, and we don't copy the data. When we take the snapshot, it is actually based on redirect on write. That means that we take a pointer reference to all of the metadata and data at a certain point in time, and then we keep the track of the changes, right? So this is very space efficient, because if you take a terabyte of data and do a snapshot, we don't copy over the terabyte of data, right? It's a slightly incremental, because we just have to store the metadata. Now, the snapshot, as a result, the snapshot resides local to the cluster, right? So what is the use of the snapshot then, right? So the primary use of the snapshot is to recover from user errors, recover probably from failed upgrades, and recover from your programmatic errors if there is any, right? These are not meant for disaster recovery, because
What about like a data scientist that's running tests and stuff, and they want to
yeah,
be
exactly, yeah. So
if
yeah,
you had like
right.
Yeah.
Right. So the snapshots can be used to create clone, as I forgot to catch your name. Sorry. You're saying, right? It can be used to clone and create an entirely new application with the same data for someone to run the test for, right? So that's the use of snapshot, and Robin provides easy way to take application consistent backup. So this is again a copy of your data, right? It's not the snapshot. It is also incremental, and role-based access is enabled for data security. The snapshots can be stored locally or local to your data center, not in the same cluster, or can be pushed to any S3 compliant object store or NFS. We support multiple target locations for your database. Sorry, backup. Once you have
just of the persistent volume, right?
No, this is the volume as well as all the metadata about your application, right? So that is what we are showing here in this view. Let's say that you had an application that is when you took a snapshot. Originally, it had 2 nodes. Let's pretend that this is a MongoDB application or some distributed application, right? So it had 2 nodes and some data, and then you took a snapshot. This is snapshot 1, and then later on, the app was scaled to have 1 more node. Now it becomes 3 node, and then you took a snapshot. So this snapshot will have the metadata about the application as well as data as of that point. That means that if you restore from this snapshot, or if you clone from this snapshot, the application will come up like this with 3 nodes as well as the data. If you use this, it will come up with 2 nodes with data, right? And in this case, it's 4. So that is one of the benefits of using the application data as well as the data in your snapshot and backup. Right? And the backup is forever incremental, which is as a result, it's very efficient, and also you can restore the entire application in same cluster or different cluster, right? We'll show you a use case where you can port your applications from one cluster to another cluster, or from on-prem to a cloud, or vice versa, or between 2 different Kubernetes distributions, right? Okay, so that's backups. And using snapshots, it is possible to clone entire application from one environment to another environment. This gives you the ability to create environments for test or running reports, primarily used for copy data management, where you have a gold copy of your data that gets copied from production, de-identified with all the PI data, and then this gold copy of data typically used in lower environments in test and QA for running through the test. After they run through their release, the data becomes stale. They again go back to copy the data from the gold copy, right? So the entire operations can be done, automatically with a single command using Robin clone, just giving a snapshot name, and then it will create your application. So it is a fully functional application that comes with all the pods and metadata along with its clone, along with its data. So the clone is a thin referential clone. Again, we don't copy the data, so you're not replicating your storage size.
Why do you want to, why would you want to like, their images, they're like read-only images. You just really care about the persistent data. Like, I don't understand from an application perspective. I just have my images that are read-only. Like what, you know, I'm trying to just grasp the usefulness of this, because I would just want the data that's not read-only, right?
Right. So see, the idea here is, yeah, the idea here is
first time seeing this is my first time seeing the product, but I would think once your application configurations and your config map, it just doesn't make a lot of sense. I really only care about the backing up what isn't, what is it.
Right. So typically what happens when you're backing up, right? So that's a traditional way of doing things.
Yeah,
right? So,
I'm sorry to ask so many questions, but
no, it's fine. That's what.
Yeah. So I'm dangerous in Kubernetes, maybe, so thank you.
No issues. See, traditionally what happens is that you have an application, right? Application deployment is done differently, then data management capability is done differently, right? Likewise, in the past, before Kubernetes, infrastructure was handled differently, then application deployment was done differently. Now, with Kubernetes, what we have done is that we don't worry about infrastructure management anymore, because the infrastructure, part of the infrastructure requirement goes with your application deployment itself. You say how many CPU cores or memory, all these things that you want for your container, it comes up automatically, and then your application runs, right? Now we are bringing the same thing to your application from a data perspective, right? So let's say that you have a Postgres database that is running, and you probably had your database running for a few months or whatever time frame it is. You made a lot of changes to it. Now, when you are taking so now your original Helm chart or whatever it is could be different than whatever actually running, right? So when you take a snapshot at the data, so it gives you all the data as well as the metadata as of that point in time. So you can quickly replicate for like I said, like for a copy data management or creating a new environment. Or then again, if something goes wrong, when you have to you want to consume your backup, now you cannot readily consume the backup, right? So you have to deploy your application using Helm chart or whatever means that you already deployed, and then you have to restore your data to your volumes, right? By looking everything holistically, everything becomes one single command and easily manageable. So that's our reason why we look at everything from application standpoint. But at the same time, the solution gives you the ability to just continue to do the volume level snapshots, backup, and rollback if you decide to do that.
Raj, if I may make an observation. Hi, I'm Florin. I'm a DevOps engineer with Robin. Sorry, I joined late because of a scheduling conflict.
Hey, Florin.
So let me take a different tack there. So you're doing a backup, right? And you're restoring the backup on a different cluster. And I believe the question was, why do you still need the original images? If you have a volume and so the volume is writable, right? You have the original image, and what we keep is the deltas, right? The changes you make to that volume. So when you restore the app from a backup on a different cluster, what you need is on the target cluster, the bundle, which has the description of the app, the Docker images, which have the original state of the root volumes and so on, and then the backup, which contains the deltas.
You're going to need your persistent volume.
Yeah.
I mean, it's the same volume, like in Portworx, like PX backup.
Yeah.
So this doesn't quite make sense. Sorry.
So basically, you need the original.
I'm new, so I'm going to be quiet and just listen. I'm new to.
Yeah. So basically, it's the original state of that volume, which is probably the Docker image, plus all the deltas, right? All the write activity that you've done, which is in the backup. So all these three together, bundle, backup, and Docker images, are the trifecta that you need on the target cluster to restore the application to the state where it was when you took the backup.
No. See, so the thing is, let me answer you in a deeper way, right? So let's say you have we can see that during the demo. Let's say you have a Postgres database you deployed through Helm chart. Let's say the application came up and you have a bunch of data that you wrote. Now, let's say that.
I mean, you can make it easy. You have an application, it has 3 images, you have a persistent volume, you take a backup of it, you re-push out that application, same images, and you just move the snapshot over, you move your back, you restore your back.
Right. No, got that. Right. So let's say that your application has different volumes, right? It all depends on Helm chart. So you have to, as a DevOps programmer or whoever is managing that, right? They have to write, let's say that Bitnami provides or someone provides a Helm chart, you cannot consume that. You have to write something on top of it to make sure that it works for your snapshot, your clone, right? Because when you are restoring your clone or restoring your backup, you are actually, in a sense, creating a new PV. That new PV needs to be then mounted on the pod that is going to come up when you're creating a new Postgres database, right? So all of this requires work. With this approach, you don't have to do any of those things, right? It's a simple command. It's operational simplicity. You can write all you want on top of it and still achieve the same result, right? It's one click and one simple command, while you also have the option to take the YAML file and then run the YAML file to create the snapshot and use the snapshot to create a clone and then attach it to the pod after it comes back.
Could you repeat that last piece one more time?
So let's say that when your database, you have a snapshot, right? A volume level snapshot. Now, your cluster, Kubernetes cluster went for a toss, right? Now, what would you do to bring back the
YAML file specifically?
Now, your cluster is gone, right? Let's say that your cluster itself is gone, right? That's the DR scenario. Now, your PVC is sitting, let's say, in some object store. Now, how would you recover your application and how long it will take? And in order for you to do that, as an application developer, what are the things you should have done, right? See, at the end of the day, it's software, right? If it is software, it can be done. There is no rocket science here. But what we are trying to do is that we are trying to reduce the amount of effort that is required to deploy each and every application. So in this case, right, let's say that your storage volume is sitting in S3. How will you recover that? I'm not saying that it is impossible to do, but it's going to take time, right? So because you have to redeploy your Helm chart with the image in the target cluster, and then you have to restore that backup.
Well, hopefully when you deploy the application, you deployed it with a replica set, so the application didn't go down because the pod.
The replica set is not going to be useful if your data center is gone, right? Unless you have your replica set.
If you're using technology like Portworx, though, right? You could do replica sets across region, so there's no problem.
No, when you do Portworx, so walk me through.
Like with Portworx, right? You could do a replica set that is cross region. You know what I mean? You could also do things like Kmotion. Sorry,
right? So
I'm just not quite understanding. This seems like it's
no. What is your RPO and RTO to bring back your application?
Yeah, it would still be running.
So you have active, and then you're replicating your. So that is a totally different use case, right? We are not talking about.
That's what a replica set is. It's an identical pod, right?
So you are saying that you have two replica set spans 2 Kubernetes clusters. Is that what you're saying? So you have 2 Kubernetes clusters running in 2 different data centers, and the pods are spanning across 2 different.
You could have a Kubernetes cluster span multiple data centers across regions, right? You could.
that is theoretical, right? Because you have a lot of latency things going on.
Yeah.
And yeah,
I haven't seen a Kubernetes cluster that large, but you know, I know that that's the way the Portworx works. It's just, this just seems a little odd. Sorry.
Right. So it is not, it's not a production use case, right? Wherever you go for fault tolerant and for so many other reasons, people don't like spanning Kubernetes clusters across multiple data center. It completely beats the purpose of the DR, right? You have to isolate your fault domains. Why do we have multiple data center in the first place? Why enterprises locate, create multiple data centers and then no, let me finish, right?
Yeah, no problem.
Yeah, so why they geographically isolate and locate data centers in different world is that they want to isolate the fault tolerant, right?
Look
so now
in Anthos, it's the same cluster. You're peering your service mesh. I don't quite understand what you're talking about. Sorry.
Okay. So you are saying that
I'm saying Kubernetes clusters span across data centers, and you peer your service mesh, and you know what I mean. You have a continuous cluster, right?
So
somebody else hop in? I mean, we have a whole team full of people here. Dan, do you know? I mean, am I not right? That's the way hybrid Kubernetes works. You know, you're going to put down your you know, you keep your master nodes up top. You can put down your worker nodes. You have a Kubernetes cluster, right? So
Well, yeah,
I'm just trying to, you know, I'm just trying to say, from my understanding, I could be wrong, you know.
No, see, it's a spanning cluster, not just Kubernetes cluster, right? Any application across data center is a problem still everyone is trying to solve, because that's not a technology problem, that is a physics problem, right? It all depends on the latency. If the data centers are you know, far apart, and then if your latency is not within the range, none of the distributed application will work, because every distributed application is trying to solve this problem, because it's all at the end of the day comes down to latency. Okay, so of course, if a Kubernetes cluster can be deployed in a distributed data center, Robin also works like that. You can have a pod that can fail over to other data center, and you have a replicated volume whose copy will be in other data center. It's a business as usual, right? We do that all the time with AWS availability zones. But what we are trying to see is a real production use case where Kubernetes clusters not commonly spread across multiple data centers. Okay, and it's done for so many lot of design considerations, right? To avoid split brain in case of a data center shutdown. You cannot have for example, a distributed cluster like Elasticsearch with master nodes spanning across multiple data center. How would you solve the split brain problem? Will you? You have two data centers. This problem cannot be solved. There are three master nodes need to be available to always form the quorum. How would you solve that? So that is why people go for asynchronous replication, and they have different cluster. They replicate data from one cluster to another cluster, but it is a completely different cluster to handle this problem. Okay, I think we've spent a lot of time discussing that. Let's move on, right? So that's the use for the clone. Now let's talk about the multi-cloud portability for your application, right? With Robin Snapshot and backup, you can take a snapshot and push your snapshot as a backup to any of the S3 compliant object store. It could be S3, GCS, any S3 compliant object store, right? Once you have the backup there, you can bring that application in any cluster. So you can move from on-prem OpenShift, and then you can bring up your data in, your entire application in EKS. So this is one of the reasons why we look applications at the application level. So you are not locked in at the cloud level or at the Kubernetes level. So we can port applications from one Kubernetes to another Kubernetes because we have everything that is needed to bring up the application, right? So in addition to that, we also provide built-in feature for RWX And there are there are common use cases for our read write many use case. Right? Okay, so that's the futures. I mean, I'll stop here if you have any questions. If not, I just want to quickly run through the deployment, management, and observability that comes with Robin for running your stateful workload.
Can I possibly jump in with a question?
Sure.
Coincidentally, I'm just sort of listening in today, but coincidentally, I'm going to be attending a product demo of a product called Delphix later this week. Is this a similar product to that, or am I in the same ballpark or not?
So I think Delphix, as I understand, it's a backup, and I think it's a backup solution for databases, right? So we are not just backup. We are cloud native storage, software defined storage that provides stateful storage capabilities for your Kubernetes cluster.
Okay, thank you for answering that.
It seems a lot like Portworx, where you're storage typing, you can put any storage there, it's going to auto type it, so it looks very similar to that.
Right. So we have a lot of.
Or do you get that a lot from when you're working with customers? Are you compete? Is that like the competing product for you? Because I mean, this is almost like Portworx to me.
Right. There are a lot of software-defined storages, and Portworx is one of them. Robin is one of them. There is a few more. I think there is around 15 or more CSI compliant storage vendors.
If you had like a chart, right, that kind of gave a competitive differential, I'd like it, because Portworx is something that I'm going to be talking about with customers, and I would want to talk about Robin IO too, and being able to give a competitive advantage. So
yeah, sure, we will share the details with you. We have a lot of things that we can provide you. So is in your solution, do you go with one Kubernetes distribution versus other, or when you're offering solutions to your customers, is there a specific Kubernetes distribution that you prefer?
Are you?
Okay, so let me move on to the maintenance and deployment, maintenance, and troubleshooting. So the deployment itself is very simple. We are in multiple marketplaces, including Google and IBM and Red Hat, OpenShift. Robin, or you can download Robin from our download page. It can be installed as an operator from all these marketplaces, or if you are using Robin installer, it actually natively installs in Kubernetes, and it installs. We deploy an operator as deployment, and then the Robin storage itself is deployed as a daemon set within the Kubernetes cluster. And the install takes about 10 to 15 minutes, and it also checks for all the prerequisites and then completes the install. And this is what it would look like once the installation is successful. And once it is installed, Robin typically comes with 3 storage classes. One for replication and one for a standard. And then you can create multiple storage classes using different options, right? Let's say you want to have a storage class with replication, but at let's say the rack level, then you could create a storage class and then use the storage class when you're deploying your application. And also we support multiple other features like compression and encryption, etc. So typically, you would create a storage class for each one of these combinations to use for your application. Right? This is a pretty standard Kubernetes way of handling things. Right? And then finally,
installing Kubernetes, though, I'm going to install it on I'm going to be installing it on Google Compute Engine You know,
GKE.
I'm not going to be installing it. I don't know. I haven't done it in Nutanix, but I guess that's there. But if I'm in the cloud, I'm not going to be deploying it. I mean, this doesn't really make sense. I'm just saying.
So what doesn't make sense?
Most of your presentation.
Okay. So the deploying on GKE. No, I didn't understand your question. What was the question?
What you're saying, you know, you're just talking about deploying on hyperconverged. If I'm in a cloud, right, I'm not going to be deploying on hyperconverged. Sure, if I put a hyperconverged system in an Equinix data center, I could do that with a product like Nutanix, right? You could do Kubernetes that way. But typically when I'm deploying Kubernetes, I'm deploying it on some sort of you know, compute, right?
Right. Yeah.
Or Google Compute Engine. It's not hyperconverged at all. So what's the value prop of the product when you're in a cloud provider? If you could kind of outline that, I'd love to hear it.
Yeah, sure. I have a demo that it's where we deploy Robin on EKS, right? You know.
Yeah. Okay. Yeah. So that's not hyperconverged though.
No. Yeah. So we were talking about hyperconverged is one of the things, right? It's not the only case. So where this goes with any Kubernetes distribution, it is managed or it is if it is deployed with on-prem. So you get the same features regardless of you know where the Kubernetes is running, right? So did you have any other question?
No, I'll be quiet.
Okay. All right. Okay. So that's the storage class. And let's look at, you know, from an observability standpoint, you can collect all the logs for all the pods and everything with a single command, and the logs can be pushed to if you so the logs are required to debug, right? And there's a lot of logs that you have to look for in case if you when you're requiring support. The logs can be collected and stored in central place for debugging, and the storage provides a Prometheus export, which can be customized and you can create a dashboard to monitor the storage metrics. And you can subscribe to events and alerts. When the events or events reach certain threshold, you can be notified and alerted. And everything that runs in Robin has a job which has an ID. It is typically more than one or more jobs. You can each job has its own log, so you can see at a job level what's happening and find out if there are issues. And finally, we have a tool called as Sherlock that provides app to spindle visualization. Basically, if you give the app name to the Sherlock, it goes and gives you all the information about all of the pods and objects and volume and everything down to which drive it comes from. Now, see, this can also be done manually, right? You have we are not reinventing anything here. We are making it easy for the users to consume it, right? So if you are someone who just want to run all the commands by yourself, you can definitely do it. But the Sherlock again gives you one single command to capture everything in one place, right? It instead of running 10 different, 20 different commands to locate where things are, you can simply run one command. So that's what we are trying to do in terms of deploying and doing all the data management, right? One simple command or API request or a UI, right? We also have a UI, so you can use one of this and then simplify the data management and of deploying and managing your application. Okay. All right, so that's for the decks, and I'll go and quickly give a demo of our product in action. While I'm bringing this up, does anyone have any questions? Okay, So I have a Kubernetes cluster. It's a EKS cluster. It runs. It has 6 nodes. Obviously, the management plane is sitting. It doesn't show here. It's EKS. So all of these are 6 worker nodes.
If it was EKS, that's not right. It's EKS CTL. I'm sorry. Is this like some sort of joke?
What is that? What are you talking about?
Oh, when you're in EKS, it should say EKS CTL.
Okay. So I'm not sure how much you understand about Kubernetes, right? Every Kubernetes engine, regardless of OpenShift, you run OC command, and EKS gives you EKS, but all of them provides a kubectl command. So just every Kubernetes works.
But you could map the command for whatever you want it to be, I guess, maybe.
Yeah, we could ideally do that. So let's try to okay, so we have a kubectl get nodes. Yeah, I have to log into Amazon console. We will have to look at that as well. So we'll see that. So kubectl get nodes -o wide. That gives you even more information, right? So it gives you what is the external IP, and then all of these things that goes with the cluster. So basically, I'm just running this command to show that there are 6 nodes with the EKS, and we have deployed Robin on this cluster, which can be checked by again kubectl describe -n Robin IO. Okay, so this shows our deployment, right? So there are 6 nodes on the EKS cluster, and Robin is deployed on the EKS cluster. It is Robin services are running on all the 6 nodes. You can see that, and each of the nodes have a role, right? So wherever you see S, that means it's a storage. And wherever you see role as M and S, that means it's also acting as a manager as well as storage. We don't recommend this for production, but just because this is a demo, we are co-locating. We are even consuming storage from the master node. Otherwise, there will be dedicated 3 masters, and one of them will be active. So in this case, there are 3 masters. One of them is active. If something goes wrong with this host, one of the other 2 will resume the master role, right? So that gives you a HA. Now, what was your name again? When you asked about whether it is EKS or hello, can you guys hear me?
No, I can hear you. I'm on mute. Sorry about that. I went on mute. I don't want to keep on interrupting you.
Yeah. I see, but every time I'm trying to see who's talking, then somehow I'm not getting that. Is that Jeffrey or Russell?
Who is Jeff?
Okay. All right, Jeff. Okay, so let's look at this, Jeff. Let's take a EC2 instance. So this is our console, right? So Robin console, and I have instances running. Now, let's search for my nodes, right? Because that's so these are the 6.
What do you mean it's like a Robin console? That's just, you're just an EC2. Those are 6 instances. Where's the
console? No, this is not a Robin console. What I'm saying is that this is 6 nodes.
You just called it a Robin console.
Okay, that's just a tip of slip. Okay, so these are the 6 nodes, right, that we are talking about. These are the EKS nodes, and this is what you would see in the command that we ran, right? When we ran kubectl get nodes, and this is what you see. So you see the external IPs, and that's what you would see here, right?
Yep.
There is, okay, so now you are convinced that it is a true EKS cluster. We are not fabricating anything, right? Okay, so I just described this, Robin cluster, which is running. And now let's go ahead and deploy an app, right? Postgres application. So before that, let me do one more thing. Kubectl get SC. Right. So this is all the storage classes that are there in this cluster. When Robin is installed, it by default comes with these 3 storage class. And I actually created this for, just to show some demo, right? So creating a storage class is, again, it's a standard Kubernetes way. So if I do this cat, and you can see that, this is a standard Kubernetes way of deploying it with the replication 3, and we are asking fault domain rack, right? So now, when I run the same, when I run the command Robin host list on this cluster, this is going to give me a view where you can see that it gives you additional information, right? What is the availability zone, and how your this gives you an idea, right? Because you have two nodes each on each availability zone, 2A, 2C, 2B. Right? So now, if you are deploying an application with 3-way replication, Robin will, with the rack as a fault domain, Robin will place each of the replicated copy in each one of these availability zones. So if one of the availability zones were to go down, your data is still intact, and your application will continue to serve your data. Okay. So let me go ahead and quickly deploy an application, right? So let's go ahead and deploy this. I am creating an application. Oh, hold on, sorry. I had issue here. Okay. Okay. So I'm actually deploying a Postgres database from the Helm repo. So let me do a Helm repo list. So I have a number of repos configured. So I'm just going to take one from the stable, and I'm just going to deploy a Postgres database. So as you can see, to this Helm chart, the stable PostgreSQL, I'm passing this argument, which is saying that, hey, give me volumes from using Robin storage class, right? So the rest of everything is, the parameters that are passed to the Helm chart to create the application. Hold on. Sorry about that. Just give me 1 second. I think I had some issue with the.
I believe it's just one space. Between Bitnami and PostgreSQL.
Where do you see Bitnami and?
Between Bitnami and PostgreSQL, there's a space. I believe that's the problem. At the end of the second line.
Okay, got it. All right, so that's what it is. Thanks, Florian. Yep.
But look at that. Your persistence storage class equals Robin.
Right. So yeah. So let's look at this. Right. So we just created this. So this is the command that we are using. So we are, because see, in every cluster you can make any storage class as default. if you make that, then you don't have to pass this, right? The Kubernetes will automatically use the default storage cluster to provision it. In this case, Robin is not a default storage class here, so we are actually explicitly passing this parameter to deploy our application. This is what you would do regardless of a storage class, right? It can be any other storage class other than Robin. If it's not default, it needs to be passed. Okay, so let's run this Helm command and see what's happening. So I just created this PG movies. It is running. So let's look at all the components that go with this app, right? So this is a PG movies. This is one of one, which is running, and it has all of these objects, right? So let's also look at if I do a kubectl get pvc minus n as Robin, and you would see the PVC, which is bound to the pod, and it is 8 GB, and its storage class is Robin, right? So this clearly says that this is a volume that was created by Robin, and it is mounted to this pod. Now let's go ahead and connect to the Postgres database, and then insert some data, right? Okay. So I exported the password, the secret from the secret. Now I'm connecting to the Postgres database. We are inside the Postgres database. And let's create a database. Let's call it as testdb, and let's do. By the way, these are standard Postgres commands. Let's do C testdb. I connected to testdb, and let me create a table called movies. Okay, I just created a table, and then let's do a select star from movies, and it will not have anything as expected because we just created the table, right? So it's 0 rows. Now let's insert some records into this table. All right, so insert 9 records. Now if I do again select star, you will see all the 9 rows. This is nothing new. It's all Postgres. We inserted some records and we checked that the records are there. So let me switch to another shell. Now if I run here, the PG movies, if I in a query for the information, you will see that Robin has all the metadata about that Helm application, right? It has a secret, persistent volume, and the services, stateful set, and all of those things. So now what I'm going to do is that I'm going to create a snapshot, and then once I create the snapshot, I will simulate an error condition. I will go and delete some records, and then we'll use the snapshot to roll back, and we'll see how easy and simple to do that, right? So now I'm creating a snapshot for the application PG movies, and I'm saying that the snapshot contains 9 records. That's what we had. We are connected to the database in the other window, and let's see how once the snapshot is done. Okay, the snapshot is done. Now if I do the app info again, it will show the details about the snapshot. I should do app info PG movies. Now this will give me the details about the snapshot, right? So there is a snapshot with an ID, and which was just created, and now it has the data as well as the metadata of the application, right? So let's say that I'm still connected to this database. Let me go ahead and create an error condition by deleting some record, right? So I just went and deleted a record, which is this one. And if I do a select star movies, you will see that there are 8 rows, right? We originally had 9 rows. Now we had 8 rows. This is just a small, database update, just to show that there was a user error or a programmatic error that caused one record to be inadvertently deleted. Right now, how do you recover from that? Right? Imagine if it is more than one table and multiple records, it'll be the same thing. So you will leverage Robin's snapshot here, and then just do one single command to restore your application and data. Okay, so this is the app that I'm going to restore by providing the snapshot ID. Right? Okay, so Jeff, in your case, right? So if you don't look at application as a holistic, right? Now what you have to do at this point is that you have to take a snapshot. We would have ideally taken a snapshot of the PVC. Now your application, you can restore. You cannot restore because, sorry, you have to go and create a clone of your snap.
Usually, I'm going and presenting storage, right, to multiple hosts in a Kubernetes cluster, and that volume. I'm taking a snapshot of that volume, and that's kind of that, right? And then you could roll back with that snapshot. So you just have to.
Let's see. What I'm saying is that you can do that, right? So you can do that here also. But this does all. See, you take a snapshot and you for a volume, and then you have to clone that volume, because snapshot is not the complete data, right? You have cloned that, and then use that clone to again mount that on the restored application, right? All of this is done with one single command, right?
Well, I'm going to mount it. I'm going to mount it to the host. I'm not going to mount it to the application, right? I'm deploying a namespace. I'm deploying an application and a namespace, yada yada. Sorry, it's kind of difficult to get the presentation from my point of view.
So when the volume is the volume for the pod is mounted on the pod, right? Regardless of if you're going to mount the volume at the host. Why would you do that? Because then
I'm presenting the volume to the host, but then I would do a persistent volume mount to the pod, right? Is that right?
Yeah, you have the volume mounted. Are you talking about the EBS volume?
I can't understand what you said. Sorry, again.
Okay. So are you talking about the EBS volume? Because the EBS volume itself is mounted to the host, but then we carve out the volume that is required by the application, in this case, Postgres.
I thought you said that you take the EBS volume, if you're looking at it from a non-hyperconverged perspective, so a non-on-premise, and you're up in the cloud, you're going to be taking the, and if you were in Amazon and like an EBS volume, right, then you would storage type that, right? Because it would have some sort of performance characteristics like Portworx does.
Right. Yeah.
Yeah. Sorry.
So we take the EBS volume, Robin drive list, and the EBS volumes are attached to the EC2 instances in this case, right? Each EBS volume is like 100 GB, right? Now, for our Postgres,
I think for me, what really made me understand Portworx was when I went through the lab and did it. You know what I mean? So
yeah. So if you try Robin, then you will probably understand. See, this is the thing, right? So this is a EBS volume that is attached to the host, right? Now for the Postgres, when we deployed, it is asking for a volume of 8 GB, right? So we actually carve out a volume from one of these EBS volumes, and this volume gets mounted to the pod, right? This only has the pod has the visibility to this volume. Right?
Yeah, you're only claiming part of what you're presenting. Yep, that's a persistent volume claim. Yep.
Right. Okay, so this volume is presented, and then now that we actually, as part of this, we actually removed one record. Let's I just wanted to recap, right? We did the restore here. The restore was complete, and if I go back and run the same command here, you will see that there is a small blip because we restored the application. Now, when I do and select star again, you will see that we put the restored the data, right? So we were missing the June 9, which was our 9th record, and we are back. So that is a quick way to restore your application from your snapshot, and then throughout for all the data management functionalities, Robin uses the same approach, where one single command helps you to create clones, backup. The backups can be used to bring up your application in the same cluster or a different cluster that is running anywhere else, either on-prem or in different clouds. Right? You could take a Postgres database that is deployed here, and you take a backup and then move it to GKE or Azure, where another Kubernetes is running. But this is all possible because we take the snapshot at the application consistent level. Okay. Yeah, I think we are at the top of the hour. We have 9 minutes. I want to stop here. So that's I couldn't get to the other part of the demo, unfortunately, but we are available. I'll just bring back my slide. You can reach us through our Slack. Our documentation is available at docs.robin.io. You can download the product to run on any Kubernetes. It is free for life if you are using Express, and we provide support if you're taking enterprise, right? I just want to pause here, and if there are any additional questions, I'll be more than happy to answer. Jeff?
I think I more than asked questions. It didn't seem to, I don't know. I don't want to say anything rude, but.
You have not. Yeah. No, you have not said anything. You have not said. You haven't said even a small thing rude, right?
Yeah. I apologize. Sorry about that.
No issues. We are here to discuss, right? So.
Yep.
I think something transpired from here. So. So there are a lot of. I don't want to compare ourselves directly with our competitor over this video, but we'll be more than happy to work with you to. Make you understand, what are the differences, right? There are, we built everything from ground up as a cloud native storage. There are other solutions who are actually ported to, to work with Kubernetes, right? We are different in that way. And then we don't use any host-based file systems because there are a lot of constraints with that when it comes to performance. And when there are maintenance problems, right? Like let's say that if a disk goes down, you don't have to put the whole host into maintenance mode, while some of the competitors require you to do it. With Robin, you don't have to do it. You can just remove the disk or mark the disk as faulted and move on, add a new disk. It is easy for when you're operating in cloud, but this is a very, very commonly encountered situation in enterprises where you're dealing with x86 commodity boxes, because SSD failure is the norm, right? Once it reaches life, it keeps failing. So these are some of the enterprise characteristics that Robin brings, and which is running in a lot of Fortune 500 companies, huge enterprises, and there are petabytes of data that has been running on Robin cluster for quite a few years.
Hey Raj, I had a question.
Sure.
Do you on your website, are there any labs or workshops that we could walk ourselves through to kind of get the better gist of we wanted to understand it by ourselves? So in the docs, it can point us to it.
Yeah, the docs will give you the step-by-step instruction to deploy Robin on any Kubernetes. And then we have a tutorial that will show you how to deploy. I think we have like 7 or 8 databases that we have tutorials for. You can deploy those databases using Helm chart, and then use Robin to do data management.
Okay, cool. Thanks.
All right. Thank you very much, Raj. It is always a good idea to be as accommodating as possible. You never know where there is going to be a love connection, when you're dealing with solutions. And so, I appreciate y'all hanging in there. That is interesting. That's interesting. Went a little bit long here, but that's awesome. Sometimes it's good to have a nice long presentation. Keep an eye on the channel. We've got another meetup in just a couple weeks here, and like I had mentioned, we're planning on going live with DevOps Days Houston here in September 21st and 22nd. It's supposed to be live and in person, unless something drastic happens with lockdowns or mandates or something. So I appreciate everybody jumping on, and look forward to seeing you at the next meetup.
Thanks, Dan. Thanks, everybody.
Thanks, Raj, for the present.
All right, thank you.
Thank you, Raj.